All right, our last lesson in Unit 6 is number 15, where we're going to sketch some logarithmic functions. Now, if we were in class, I probably would have you do this, which one doesn't belong, and explain why. But because we're doing a video lesson, we'll skip that for now. Now, our first activity has us looking at these functions and graphs and matching them up. So we've had a lot of practice with exponential graphs so far, so let's get those out of the way first. Now, the first one, 3 to the x power, we know that's going to be growth, and our y-intercept, when we substitute 0 in for x, we should get 1, and it should be a growth function. So that's what we have right here. Okay, this is a growth function, and our y-intercept is 0, comma 1. So this is f of x equals 3 to the x. So f of x equals 3 to the x power. Okay, so we got that one done. Now I look at j of x, it's 1/3 to the x power. So that's going to be an exponential decay function because 1/3 is smaller than 1. So it's going to be decreasing as we go from left to right, but our y-intercept is still going to be 1 because when I substitute 0 in for x, I get anything to the 0 power is 1. So that's going to be graph number 3. So that's going to be j of x is equal to 1/3 to the x power. So now our last exponential function, is m of x, -3 to the x power. Now what this is really in disguise is -1 times 3 to the x power. Okay, that negative in front of it does not make the 3 negative. It makes there's an invisible -1. If I wanted -3 to the x power, it would be written like this, with parentheses around the -3. But that's not what we have here. So the only other exponential function we have is graph 6, which is a reflection of graph 4 over the x-axis, which should make sense because we know if we have a negative in front, that is a reflection over the x-axis. All right, so we got the exponential ones done. Now, the most basic logarithmic graph has a vertical asymptote at x equals 0, and it increases from left to right. So graph number 2 is going to be this one right here. And when we graph more of these, you'll see this will make a little bit more sense. Now, if that's graph number 2, you'll notice graph number 1 is the reflection over the y-axis, and we know if we do a negative x, that is from our transformation of functions unit, a negative x reflects over the y-axis. So this must be k of x, which then just leaves graph 5 having to be h of x. H of x is log base 1/3 of x. So describe some key features of graphs of logarithmic functions. So they have a vertical asymptote at x equals 0. Right? All of these log graphs, you see that there's like an invisible line here at x equals 0. So you see like graph number 1, we still have that asymptote there, and all the x values are negative because we had that reflection. Oops, this one, sorry about that. This one should be negative x because we have that reflection over the y-axis. Now, how are the graphs of logarithmic functions different from the exponential functions? Well, the asymptotes have different equations. You have different equations. It was always x equals for the logarithmic ones. For exponential functions, our asymptotes were always y equals. You may also notice that the exponential functions had no x-intercepts, and the logarithmic ones had no y-intercepts. And that's because they're inverses of each other. So exponential had no x-intercept. Logs had no y-intercept. Now, once we start transforming the functions left, right, up, or down, like that may not always be true, but based on these graphs up above that we're looking at, that is true for the log and exponential functions, that they don't have the um, the same intercepts. Now let's go on to the next page and we're going to graph a log function. Now the log functions, we always start with a table, an x, y table, an x, y table, and the points are always 1, comma 0, and b, comma 1. Well, what's our b value? That's our base right here. So in this specific example, when we make our xy table, it's going to be 1, comma 0, and 2, comma 1. Our vertical asymptote is going to be x equals 0 because we don't have anything being added or subtracted inside the logarithm. So we're going to draw this. Now you may be wondering, do we have to make an extra table? Not right now, because there are no transformations for this function. We're not adding or subtracting anything. We don't have an a value in front. So that's why I just have this one table here. So we have 1, comma 0 and 2, comma 1. So our graph will look like this. Now, when we do some transformations on the next page, we will have more than one table, and we'll do a different transformation for each table. The nice thing is that there's only 2 points that we have to plot and put in our tables, but you do need to remember that the shape of the graph is like this. A lot of people will just see the 2 points and want to draw, something like that going through the asymptote, or they'll draw, or they'll draw something like this, but then this side will go up too quickly. So a logarithmic graph grows very slowly. A logarithmic graph grows very slowly, so it should look something like the orange graph there. Now, we're not going to discuss the two different strategies that these students use to sketch this logarithm. We're going to do it the way that we did it up here. So on this page here, we're not going to do the sketch and swap activity. What we're going to do instead is going to graph two separate log functions. We are going to graph, we're not going to graph exactly how they're written down here. We're going to make a slight alteration. Like for this one, we're going to do, our equation is y equals log base 2 of x. I'm going to do x minus 4 in parentheses. And over here, we'll do it exactly as written. Log base 2 of 1/3 x plus 4. All right, so the first one, we're going to make our table. We're going to make our xy table. And it's always 1, comma 0 and b, comma 1. Then for our second table, because it's x minus 4, we're going to have to add 4 to all of our x values. So it's going to be now 5 and 6. and still 0 and 1. Again, we don't have any other transformations. There wasn't like a 3 in front of the log, so that's why we only have two tables here. Our asymptote, our vertical asymptote is going to be at x equals 4 now because of this minus 4. So 1, 2, 3, 4. And then when we plot our points, 5, comma 0 and 6, comma 1, that's going to make our graph go like this. So that the table work that we did for exponentials is coming back. We're starting very basic right now, where we only had one transformation in this problem. We just had to shift to the left 4 units for the x's, and that was it. Now for the second one, there should be an x here. For the second one, we have two transformations. We have a plus 4 on the outside, which is going to add 4 to all the y values, and we have a 1/3 x, a 1/3 inside the parentheses with x. So what that's going to do is, instead of multiplying, which you would think that would mean multiply the x's by 1/3, it's going to multiply the x's by 3, the reciprocal. You know, weird things happen when we start transforming, the x part, the stuff inside the parentheses. So our vertical asymptote is going to be x equals 0 because we don't have any addition inside the addition or subtraction inside the log. It's just 1/3 times x. All right, so we're going to start with our table, xy, 1, comma 0, and the b value again is 2, comma 1. Now I'm going to take care of this right here, this 1/3 x, by multiplying the x values by 3. So it's going to be 1 times 3 is 3, and 2 times 3 is 6, 0 and 1. And then our last transformation is going to be adding 4 to the y values. So we have 3, 6. 0 plus 4 is 4. 1 plus 4 is 5. So now I'm going to plot these points. 3, comma 4. So 1, 2, 3, comma 4. 1, 2, 3, 4. And 6, comma 5. So our graph will look like this instead. And again, I want to point out that every time we do a new transformation table, one of the columns stays the same, and a different one, the other column will change. Something will happen to it. All right, so let's go to the next page, and instead of graphing log base 3 of x, what I want to graph instead is 2 log base 3 of x plus 1. Because we haven't done anything yet today with a 2 or a different number in front of the log. We've also only done a base of 2. This has a base of 3, so it's still going to be 1, comma 0, but now that our base is 3, it's going to be 3, comma 1. Then we're going to multiply all the y values by 2. So 1, 3, and then 0 times 2 is 0. 1 times 2 is 2. And then this x minus 1 means I'm going to take all the y values and subtract 1 from them. So 0, and then 2, and the y values stay the same. Our vertical asymptote is going to be at x equals -1. So I'm going to draw that in. Then 0, 0, and 2, comma 2. So our graph will look like that. So just keep in mind that the base, when it's not, we only did this problem where the base wasn't 2. So that's why we had a 3 right here. The other ones were all 2s in that spot. So just make sure you're paying attention to that. Right, so that's it for graphing logs. You have a couple in your homework where you're going to do that, where they're maybe a little bit simpler than this, but just we want you to get the idea of how to graph these with the tables. So thanks for watching. Make sure to like the video and subscribe.